such.
On the quiz. On the quiz. Usually I come in and act like I'm in a, and I didn't feel like doing it today because I really don't feel well. Usually I come in and act like that the elephant wasn't supposed to be there and I don't know how it got there and act like I'm all mad and just say do it anyway, shut up, I don't care. Take your grade, and then everybody gets all mad. But I didn't think I'd do it that way today. The whole point of this, those of you who just quit on these 2-column proofs, just give up on them. Is there any real reason to do that?
No.
No, sir.
I can't force you to do anything, all right? Now I know some other teachers are more loving and caring and, oh, Caitlin, but I want you to do so well because I love you so much. I'm sorry, but you go to Mrs. Barnes or something, one of the other teachers. That's not Ebersole. I'm sorry, I'm too old and Mason, I'm too old and crotchety to be that way anymore. All right? I'm sorry that you had to have me when I've been teaching for 30-some years, but that's just when you were born. So I can't do a whole lot about it. So even if the alpha is on that paper there, can you still do this 2-column proof?
Yeah.
Yeah, and I thought I'd fixed how many steps there was, but I forgot to do that. That's one of the things I forgot to do. First thing it said to do was redraw the picture. If I redraw that picture, you should probably be able to tell that it looks something like. Does everybody agree with that?
Yeah.
This is A, that's D, you could see that. Then we read the given information, and it says segment BD bisects an angle. Where do you think B is then?
On the left.
And then it's got, out here it says angle ADC. Well, where's C have to be at?
The bottom.
Does the elephant affect anything now?
No.
All right, you got the picture, and if you just try and separate it off, then you should be able to do the 2-column proof. Just looking at what we're trying to prove, it says prove segment AB is congruent to, what other segment do you think it is?
CB?
CB or BC, either one? All right, is that correct?
Yeah.
Yeah.
I'll put DC.
DC?
Well,
Let's see once
DC.
let's see once we get some of this other stuff. It says BD bisects angle ADC. Angle ADC is that angle there, right?
Mm-hmm.
So what do we know about these two angles?
They're congruent.
So I'm gonna mark them as congruent. Somewhere in our 2-column proof, we're gonna have to put that those two are congruent, right? Then it says BD bisects some other angle that I can't read. Well, what other angle do you think it bisects?
ABC.
ABC, right? This angle. So if it bisects that angle, what do you know about these two angles? They're congruent. Now, to see which one we're trying to prove here, if these two triangles are congruent to each other, segment AB is going to match up to which segment in the other triangle?
CD.
So you're telling me that this triangle, to get them to match up, this triangle, you have to sort of spin it around? Is that the way it's going to match up?
No, you don't
Wait,
flip
what?
it.
I don't know what you're asking.
Yeah. You
So we're trying to match up these two triangles. How am I going to match it up? Am I going to spin it around or just flip it over?
Flip it over.
Just flip
Okay.
it over.
So it's BC.
So if I flip it over, segment AB matches up to which segment?
CB.
CB.
But if those angles are congruent, that means all the angles are congruent.
That's true.
Which
So,
means they're the same triangle. So all sides would be congruent.
right, but not just because all the angles. We got to use one of these four to say that the two triangles are congruent. And we're still missing, because right now we got a pair of angles and another pair of angles. Is that enough to say the two triangles are congruent?
No.
No, it has to be one of these four ways to be able to say the two triangles are congruent.
Anything.
Now, what Ethan is saying is that if these two angles are congruent to these two angles, what has to be true about this third pair of angles?
They have to be congruent.
They have to be congruent, but Is one of our ways to prove the two triangles congruent angle, angle, angle.
No.
So that won't help us, okay? Because angle, angle, angle doesn't work because all the angles in this triangle are exactly the same as the angles in this triangle, but the two triangles are not congruent to each other. All right? What's the thing that we're missing?
Side.
A side. Which side is it?
The middle.
BD. What do we know about segment BD in the top triangle?
That equals itself.
It equals itself in the bottom triangle, right? So that's a pair of sides. Now, does that S go between the two A's or out here where it's angle, angle, side?
Between.
Does everybody agree with that, that side's between the two angles? So can we prove that the two triangles are congruent?
Yeah.
And once we prove the two triangles are congruent, what can we say about these two segments? They're congruent. Statements, reasons. What's our first statement going to be? The given, which said segment BD bisects, and you can split these up. I heard some of you saying, oh no, you got to put them all in one. You could split them up. So if it bisects angle, we said it bisected this angle first, right? So angle ADC. How do we know that it bisected angle ADC? And this might take more than 6 or 7. I don't know how many steps if we split it up this way. We'll find out here in a second. So if that bisects this angle, what two angles are congruent? Name the top angle up here for me. Angle ADB. Hoping everybody's watching this, because when we take this test, what's the bottom angle? CDB. How did we know that those two angles were congruent?
Angle bisector.
Yeah.
Right, so angle bisector does what?
Splits
A segment.
a segment. Two comes
Splits a what?
angle.
Angle into two congruent angles.
Splits angle, sorry, into two congruent
Parts.
parts or two congruent angles. It's easier to write angles because you can use the abbreviation than the parts. So that's a pair of angles. Is that enough to say the two triangles are congruent?
No.
Then we said that segment BD bisected, we could do that. So segment BD is congruent to segment
BD.
BD. How do we know that? This is one that we use all the time, Ethan. Anything equals,
The reflexive property.
anything equals
Is that the
itself.
other name?
You write the reflexive property and I mark it wrong.
Okay.
Anything equals itself. Alright? That's a pair of sides. Is that enough to say the two triangles are congruent? So the other thing that we knew is segment BD also bisected what other angle?
ABC.
Angle ABC. How do we know that? That was given to us. Can I put an A out there next to that? Can I put an A out there next to that? No, that didn't tell us a pair of angles, just told us that angle is being bisected. What two angles are congruent if that angle is being bisected?
Angle A and angle C. Oh wait. It's like every time I think I'm caught up and I'm paying attention, I say the wrong thing.
What's this top angle?
ADD.
Close. ABD. Remember, the vertex has to be the middle letter. What's this bottom angle?
BCD.
CBD.
C, B, D. You guys can't believe this far in the year we're still naming angles wrong. But if I have this angle,
Are you talking about the bottom one or the side one? That okay, yeah. CB.
if I have this angle, how do you name it?
Vertex in the middle.
H.
N, you just walk around it. NTH. What's the other way it could be named?
HT.
HTN. Got to be able to name those angles. How do we know that those two angles were congruent? Same thing we said up here, right? Because what was happening to it? Being bisected. So angle bisector splits angles into two congruent angles. That's a pair of angles. Is that enough to say the two triangles are congruent?
Yeah.
Do we have three parts out there that match our our four things?
Mm-hmm.
Yeah. So now we name the triangles. Somebody name the top triangle for me. Does it really matter how you name the first one? No, what matters is, sorry about that, is that you match up the second one. What's A in this top triangle match up to in the other one? C. What's the B in this triangle match up to in the other one? B. And what's the D match up to? How do we know that those two triangles were congruent?
Angle side angle.
Angle, side, angle. Remember, if your statement is two triangles, the reason has to be one of those four. It can't be anything else. Are we finished?
No.
And if we know that we got to go past angle, side, angle, what's this next reason have to be?
CPCTC.
Corresponding parts of congruent triangles must be congruent. And what's our statement?
The proof.
What we were trying to prove, what was it? CB or BC, whichever way I wrote it wrong in there, but it doesn't matter. On the packet. I'll do a few problems. I'm sure I laid one of these somewhere.
Want to do 19?
I'll do a few problems off the packet.
Where's that?
I'll do a few problems off the packet. I'll do more if you guys are helping out. But as soon as Hannah's sitting back here looking like she's bored with it, then we're stopping. So which one?
Lactation.
Yeah.
You're just a mom.
Which problem?
13 on, or at least 13 through 15.
Which? Somebody else, Kellen, can't understand directions. Which problem?
15.
15 on the back?
Yeah.
Cameron, do you understand why I might get annoyed?
Wait,
So on this,
Start at 1.
do we want to start with number one?
Yeah.
I'm not doing all of these.
Alright, let's start with 13.
Why? What is the point?
Because I don't understand that.
It's 130.
We
I
can
don't know.
get
No,
there.
Just start at number 1, please.
No, he just said he's not doing all of them.
Obviously, but that's.
You have doing.
Yes, I have one.
Give it to us.
Do it, Mr. Ebersole. Whining all the time.
Number 12, you want to make them both now.
I'm trying to think
Alright.
if I have, seems like I drew this once. Trying to think if I have it on somewhere where I can pull it up and,
Three of copies.
so I don't have to try to draw it. Give me about 10 seconds.
You got 10 seconds.
Just relax. Kellen, yeah, I'm telling you. You will be in the hallway when I come back out there.
Okay.
God bless.
We're back.
God bless.
Why do you keep sneezing?
She's around you, and she's allergic to weirdos.
And I just got
She's allergic to dogs.
And I know for sure.
Oh, I saw that. I thought you meant that. I thought you meant the sneezing. I just thought it was you. I was like,
Yes, you can.
why?
Today's
I don't know, but probably 700 calories. Sure, you get me. I want to guess.
Dude, this guy, DMs me on Instagram. You're a hero. Can you send me your video? Just, I don't know. He's a baseball player.
You send him a video?
Somebody read to me so I don't have to keep looking back. This is supposed to be a B up here.
That's a B? Oh.
There's a B at the very top.
I thought you meant the whole shape was a B.
Come on, dude. Somebody read to me what the given information said slowly.
BCD, angle BCD.
All right.
Well, you forgot the first
Is
part, Alan.
congruent.
Did he forget the first part?
Yes, I did. ABC is an equilateral.
So triangle ABC is equilateral, so I'm gonna mark it with just my marker here. ABC is equilateral, so that is congruent to that, it's congruent to that, right? What else does that tell us?
All the angles
At all
60 degrees.
All the angles are 60 degrees. Next thing they tell us,
Angle BCD is congruent to angle BBC.
BDC. So these two angles are congruent.
That's 7.
Before we go any farther, what kind of triangle is that triangle right there?
Isosceles.
Isosceles. So this side has to be congruent to that side, right?
Mm-hmm.
And these two angles down here have to be congruent. So if that one's 7x, what's this one? 7x. Before we go any farther, because we don't want to get confused, we don't want to lose our train of thought here. What do you know about the three angles of a triangle?
I don't have any.
So what equation can I set up?
7x.
So 7x plus 7x plus 4x equals, solve that. Tell me what x is.
10.
Anybody else agree with him? It's 10? Yes, no, maybe?
Mhm.
Grab your calculators out if you don't have them out. 10, is that what we're going with?
Yeah.
So if x is 10, we found that. Let's go back in this problem right now, or back in the picture here. What's this angle over here on this side?
70.
70, so let's write that in there. That's 70 degrees. What's this one over here?
70.
What's this one up top here? 40, so write that in. So we found all those angles so far. What's the next given tell us?
Segment DE is congruent to segment CE.
So DE, that's right here, is congruent to segment CE. I'm gonna have trouble marking all these because after this one, we're gonna end up with like 3 marks, 5 marks, 7 marks. I'm not gonna put them all in there. What kind of triangle is that triangle right there then? So what do I know about these bottom two angles?
They're congruent.
So if this one's 6Z, what's this one over here? Can we set up another equation just like we did on this last one?
Yeah.
What do you come up with?
6z plus 6z plus 3z equals 180.
Somebody solve that.
The most monotone voice I think I've ever used in my life.
Z equals 12?
Yeah.
Is that what we're going with? Yes?
Yeah.
If Z is 12, what's this angle right here?
72 degrees.
72, anybody agree with that?
Yeah, I
So
think,
write
yeah.
72 in there. What's this angle over here?
72.
If Z is 12, what's this angle down here? 36, write that in there. Now we just found Z. I looked before we go on to any more given information. Some of these other things down here have Z's in them also. Could we fill in those? If this is 10Z, how much is that angle?
120.
120, so write 120 in right there. If this is 2Z plus 6, 2 times 12 plus 6, what's that give you? 30. Any more Z's z's anywhere? Yeah, there's one down here. What's 4 times 12 minus 7?
29.
29? So write 29 degrees in that angle. Is that not right?
No, it's 41. 4 times 12.
Oh, yeah, I said that.
So what is it? 41. So that angle's 41 degrees. We have another x down here. We could have done it. What was x again? So what's 10 plus 6?
10?
So that angle's 16 degrees right in there.
There's another Z.
Is there another z?
Wait, no, we already did that one.
Is that, oh, here's another x.
That's 82 degrees.
82 degrees, everybody agree with that?
Yeah.
Right, 82 in there.
So if that was 41,
Now, do we want to go back to the given, or do we want to find some stuff that we can find on our own here?
figure out some stuff.
Do you want
Just
to?
figure out some stuff. Does everybody know where we stopped off at the given at? Maybe mark it or something so we know when we go back up, we're not reading back through the same stuff over again, right?
Mm-hmm.
Let's look at this triangle. Does everybody see that triangle right there?
Yeah.
We know about the 3 angles of a triangle.
Yeah, that's 180.
So if this angle's 30, that angle's 120. Can we find this angle right here? 30 again? So write 30 in there. This triangle down here, that's 41, that's 82. Can we find this angle right over here?
Mm-hmm.
So
57?
57.
So write 57 in there.
And then that,
What's this angle over here?
Yeah, it's a
57, because it's a vertical angle.
and then the other one is
Can we find this angle right above here?
123.
123, everybody agree with that?
Mm-hmm.
Because those two have to add up to 180. What's this angle right down here then?
123.
123. Anybody see anything else that we know of just from what we have? Or do we need to go back to the given information now?
Okay, we go back to the third.
Go back to the given? Alright, what was the next given?
Did we do angle, or segment BE is congruent to CE,
Yes.
which is congruent to EF. So CE is congruent to EF.
So CE is congruent to EF, so that means these two are congruent. This one's congruent to that one.
We already knew that though.
That tells us that that's an isosceles triangle, and those two angles were 30 degrees. We already did that, so that we've already figured that out, or sort of used that. What else?
Angle CGF is congruent to angle CFG.
So this angle is congruent to that angle.
We don't know anything about the angles.
Is that an isosceles?
So that means this is an isosceles triangle. So these two sides would have to be congruent, right?
Yeah.
The bad thing is we don't know either one of those. If we knew this one was like 5 wide, then this one would have to be 5 wide, but we don't know that yet.
GCF is congruent to, or triangle GCF is congruent to triangle GKF.
Alright, so triangle GCF. Sort of hard for me to mark up here. Does everybody see triangle GCF here?
Mm-hmm.
It's that angle, or that triangle, sorry. And it's congruent to which triangle?
GKF.
GK.
GKF. That's this one down here.
So does that mean those two angles are 16 wide?
So, I'm not sure. So
Yeah, it
it
does.
said GCF, is that what it said?
Yeah.
Yeah.
So GCF and GKF, is that the way it said it? So if it said that, triangle GCF is congruent to triangle GKF. The G angle in this triangle has to be equal to what in the other one?
G.
Does everybody see that? So if this angle down here is 16y, what's this angle have to be?
16.
16y. And then if that one's 16y, what's this one over here?
16 1.
16y. Now can we set up an equation to find y?
Yeah.
What's it gonna be for this red triangle?
180 divided by, or
What's our 3 angles?
16 y plus
4y
16 y plus 4y equals 180.
Somebody solve that for us, tell us what y is.
it's 5.
5, anybody else get 5?
Yeah, I got 5.
If y equals 5, what's this top angle up here? 4 times 5 is what?
20.
So let's write 20 in right there. And get rid of all this stuff here. If this angle is 16y, what's 16 times 5?
80.
So that angle's 80. What's this angle over here then? 80. What's this angle down here?
80.
80, because they said that those were congruent. What's this angle right here?
80.
Can we find this angle down here?
Yeah.
If that's 80, that's 80, that's 80, that's 80, and that one up there is 20, what's this one down here have to be? 20. Let's put it in there. We now know what y is, so we can go back and find some of this other stuff. 4 times y is what? 20, so write 20 in that angle.
And then in the given, it says that.
That's, you're going to confuse us. What's 8 times y?
40.
40, so let's write 40 in there. We're just finding stuff that we know right now, and then we'll go back to the given here in a second. Any other y's anywhere that I've missed?
I have no clue. I
No
don't see
others?
any.
All right. Now we go back to the given. What's the next given say?
That those two triangles are also congruent to triangle JHM.
JHM. So this, the red one and the orange one is congruent to this black one over here. Well, if this angle's 20 and it's congruent to those other two, what's these two angles here? They gotta be congruent. How much are they? 80. So we can write 80 in there, 80 in there. If that angle's 80, what's this angle right over here? 80, because they're vertical angles. What's this angle right here where this J is?
20. Right?
What do we know about these two angles? They add up to
Oh, it is
180. So how much is it?
120.
100. What's this angle down here? 100.
The top angle's 23.
Where you at? This one?
Yeah.
These three angles got to add up to 180. So what's this angle up here?
23.
23. Looks like we're out of everything. So
No. One angle JLO
J
is the one with the 100 on
J
it. L.
L.
Right there would be 164 across from that 100 on L.
Right here.
Yeah, it'd be 164.
Close.
Yeah, we do know
That's 16, so it'd be 64.
Right there, that, that's 164.
It's
Right.
just 64.
Three angles of a triangle add up how much?
Oh, yeah, 64.
64.
And the other one.
And what's this one over here?
64.
64. What's this one up here?
126.
116.
Make sure you're using your calculators. Don't mess up something just because you're trying to get in a hurry. What's this one down here?
116.
So then.
We can get
Then
L
we
and
don't-
L.
Can you get this one down here? Is that the one you guys are saying?
LON is 24.
24. Everybody agree with that?
And and then angle IKL is 41
IKL.
because those four are
IKL.
because those four.
Let's go back to the given. Is there any more given information?
Yeah.
What's it say?
Triangle KFH
KFH.
is congruent to triangle KLH.
KFH. Does everybody see this big triangle here? Does everybody see that?
Yeah.
So we know two of those angles. What's those add up to?
120.
123. Could we find this angle out here then?
57.
57. Everybody agree with that? Yes, no, maybe?
Yeah, then we can get.
No, that's
Wait, what?
That can't be
that
right.
can't be right.
Yeah.
That can't be right?
No, because the other one is 120.
Should be
There's
50.
something
Yeah, it
wrong.
should be 57.
So did we do something wrong somewhere? X was 10, right? So that's gotta be 82.
I think they mean that whole angle is 82, not just that one segment. You know what I mean?
The one segment is the whole thing.
Yeah.
Like, maybe they meant this, all of F was 82.
Oh, from here all the way around?
Yeah.
Yeah, they should have marked it that way if that's what they were
I
trying
mean,
to say.
you know.
So X is 10, right? So that should be 82, maybe that whole thing. Z was 12.
Yeah, all those equal 180. Should they equal 180?
Yeah,
They do.
that's 57.
Is this picture wrong?
It might be.
I think the picture has to
I
be
don't
wrong.
think so though, because I remember I figured it out before, so something's not right.
Do I have to go back to our given?
We did something wrong somewhere, because I found the whole thing at some point.
Why wouldn't that one be 57?
Because the
So
other
that's the
big
thing, so we've messed, this one can't be 57 because you see this triangle here?
This has to add up to 180.
That has to add up to 180, and
It already
123 and 57 is 180, so that means this angle here would have to be 0.
Which is impossible, which.
Yeah, which is not right.
I mean, it could be, they just drew.
What that would be 41?
What?
How would you find that angle?
Let me look at the picture,
Tell we're trying to find out.
just to see if they, no, it looks like it's pointing at that angle.
It's 41.
2Z
Call
plus
that. I
6.
said a random number.
Wait.
Got that. 4Z minus 7.
I'm gonna say it's 41.
What is it meaning for that?
Like, how
Is it
did we
meaning
get 57?
both of those?
How did we get 57?
Like,
Because they have
See,
to
that's
add
what
up.
Kellen was saying, and
not that. Like,
that whole thing.
Yeah.
That's what I'm saying, but they should have marked it like that.
Yeah, it seems like they would have marked it
Are
different.
you actually thinking about it?
Yeah, wait, how did we get 57?
Don't actually,
That's a
don't.
good point.
57 out here?
Yeah.
No.
How did we get, how did we?
Because that big triangle has to
You
be.
see this big triangle?
You can find them.
So that big triangle has to be 180. So 41,
No,
80.
because 82 isn't that whole angle, 82 is only part of that angle.
Yeah.
Ah,
So you have
that's
to figure
why.
out the other part.
So that's not 57, is it?
So we gotta look back.
Big brain.
What's the other given? What's the rest of the given said? Oh, so let's go back to where we were at. It said this triangle, this big triangle, right, is congruent to which triangle?
KLH.
That's this triangle. Right?
And we can
So it's
figure
gonna
it out.
fold over to match up. If this angle's 23, what's this angle gonna be?
23.
That's gonna cure all our silliness here.
So this,
Now can we find that angle?
34.
34, everybody agree with that?
alright, there we go.
What other given information do they give us?
Angle F. K. L would be, no, that angle on that would be
Which one?
H.
This one?
A, yeah, would be 41.
41, so that goes in there, cause those two have to be the same. They tell us any other given information? No, yes, maybe? I don't think we ended up with all the given information, did we? We ended up with those two triangles, we haven't even used the last line of what all they told us. What's it tell us, cause I'm not going that far, I'm not gonna read it.
Segment KO,
It's congruent to
segment FO.
So this whole thing, segment KO from here to there is congruent to segment FO.
Yeah, so it makes a nice.
FO, so that's this whole thing.
But we already did that.
So this, sort of hard to see here, but this big orange triangle that I'm getting ready to draw is what kind of triangle? Isosceles.
82, 82, and 16.
So 82, 82, and 16. So we have all that already. What else?
Angle HKN is congruent to angle HNK.
So HKN, where's H at? H is up here. HKN, that's that angle, is congruent to which angle?
HNK.
HNK. So that means this triangle right here is what kind of triangle? Isosceles. So if this is 23, what's 180 minus 23?
157.
And we divide that by 2.
78.
78.
So that angle's 78.5. What's this angle down here?
No, that angle's not 78.5.
It's not?
No.
Oh, no, that one's not. This one is though, right?
Yeah.
And then how could we find just that one?
37.5.
37.5?
Yeah.
Now we have all the angles in.
I don't know, is that all of them?
Yeah. You know, which one?
Yeah.
Give you about a minute or two, you should be able to fill in all the answers.
See. A2 at the very right. Do you go where the, like, so the, where the vertex is, I think, Jake? So would you put 60 and 60? What'd you get? 31.
Can you fill in the triangles up here?
We go straight Jason comprehend our end.
Can you do something?
Mr. Ebersole, you moved it.
Where do I turn this in at?
You moved it.
Yeah, no, it looks so wonky. Where do I?
Hang on to it.
I'll hang on to it.
Jay Leno.
Get it to match up again.
Hey, Jason. Another one of these.
Mr. Ebersole, I don't have any passes, but I really, really, really need to use the restroom. Can I make it quick?
Hurry.
Thank you.
Are you driving?
We take.
So if I got it all? Yes, no, maybe? Those two places are anywhere close to each other.
They're both in Ohio.
I would not go to Florence. Well, this is 2.5 hours.
2.5 hours is not that bad.
Mason's only,
When you think about it,
like an hour.
it's not that bad. It's better than 9 hours.
There and back.
An hour there and back.
2.5 days.
There and back. You wouldn't do it.
No,
People in places.
not even closer.
But the two better.
Quickest pee ever.
Okay, but it's not Florence.
I used the last one a week ago. Cause I'm cool like that and I get my work done. I don't know. I really don't. I think if you knew it was an emergency, I think it'd be so bad.
You get your work done and then. I got my work done exactly 5 minutes before we started doing it.
So I didn't have
I know you were.
So, are we ever gonna do a test that looks like this? Cause this is pretty easy. I know we have in the past. Are we gonna do it again?
Luke, what did you just say looked easy?
Yeah, dude.
What, that?
It wasn't that hard.
Kellen, did it look easy?
It was just confusing to like.
There was a lot, but-
You guys try to get too much of a hurt.
No, it's just confusing to write the.
I didn't know how to, I didn't know what the answers
If
were
I could
until
just
after.
label it like that, and just do that.
So why wouldn't you do that?
Because we can write down all the questions, or write down the answers. That was the
Okay.
confusing part.
I think
Thank
I'm
you.
dyslexic.
That makes more sense.
I think I'm anorexic.
So we're
No.
So we're probably gonna do some.
Definitely not anorexic.
Unicorn or whatever.
Luke might be. Nope.
Yeah, it's done apartment now.
I don't know. I've seen you stretch like this. That's just. My,
That's how I stretch.
I'll be like.
I'm not, so when they say Ebersole, answer for me, all right? 'Cause I don't
Ebersole.
pay any attention.
Answer for me.
it's like the one funny thing.
How is the
Mason,
projector
you should
still projecting the marker, like the pen over top of that?
Oh, you want to take a picture of it?
No, I'm done. Oh, marker.
Rounded out. You got my phone.
I could take a picture. You get grounded.
You grounded because you lied to them.
I'm grounded because my dad told me to do my chores and I fell back asleep.
It's a pretty common occurrence to start us off. It's like he doesn't get in trouble for grades, nothing.
I get in trouble for grades.
I'm helping you.
That didn't sound too thrilled when I talked to him.
If I have a C, I'm grounded for a week. If I have 2 C's, I'm grounded for 2 weeks. If I have a missing assignment, I get grounded for a week.
That's lame. I don't get grounded unless I have an F. So
Brandon, is
keep
it
it
weird
above
to look
passing.
at your grades like every?
As long as I have a 60 or higher,
I've never
it's okay.
ever looked at
Yep.
Well, not in this test, in this test I C.
Ever.
No, for a basketball game, my dad purposely like
told him
marked
my
my
grades.
grades.
On the notes, fill in what you need to fill in on this part.
I say, I got enough, I'm good, right back up there. Okay.
Gotta hurry, because we only got like 18 minutes. Test next time.
Oh. What?
Test this time, as soon as Mike opens up his mouth again.
You said test this time. We're gonna have 16 minutes.
No, apparently it's 19. Michael Wright.
I didn't think it through, but it was something.
Some of you gonna be highly, because all we've really taken, we've taken these little short quizzes and stuff. We haven't had a test yet this 9 weeks. Do crappy on this test. And when I stick it in the Moodle, you're not gonna be very happy because it's gonna, you do bad on this test.
How much?
You might have like a 90 right now. You do bad on this test and it's gonna make the
How
whole
many
difference because
points
it counts
is
a
it?
whole bunch of points. Counts like a normal test. All tests count more So when we take a quiz, it might be worth 5 points, 6 points, something,
Is this one gonna be like 90 or?
100.
100,
All
yeah.
tests
Do you think
were
you're gonna
done.
be putting it in before the midterm?
Yeah, it'll be in there before the midterm. Well,
Will it be close?
Come on.
yeah, may not be in before the midterm, because that's Friday, isn't it?
Yeah.
We'll see.
Main session.
So what is the test gonna be over, just this and the column proofs?
That's what we're going over right now.
Right angle or that?
I'm guessing it's
When you write a whole circle.
If,
when you
is
mess
the
up,
third
it's
angle
like
theorem the
that.
first, like, two triangles, are those right angles?
It happens every single
Yeah.
time.
Okay.
Now whenever it's
So to classify triangles, remember classifying triangles on the test, there'll probably be some problems. They'll say, name this triangle according to its sides and according to its angles. So it's going to have two different names, right? Every triangle's got two possible names. If you're naming it according to its sides, then a scalene triangle that has no sides the same. Isosceles triangle has two sides the same. Equilateral has three sides the same. If you're naming it according to its angles, an acute triangle, all three angles are acute. An obtuse triangle has one obtuse angle, and a right triangle has one right angle. Equiangular triangle has three equal angles. What do you know about a triangle? If it's equilateral, then it's also what?
equal.
Equiangular. So if it's equal, you might want to do this. If it's equilateral, it's also equiangular. And what do you know about the three angles in the triangle if it is equilateral or equiangular?
60 degrees.
They're all 60 degrees. Exterior angle theorem. Remember when we were doing this, Caitlin did really, really well with this exterior angle theorem. She wanted to use it all the time, it seemed like, even though sometimes it might be easier to do something else. So if I know this angle, and I know this angle, this is the exterior angle, these two added together always add up to equal that exterior angle. So that's the exterior angle theorem. Ethan O was using this one a second ago. If these two angles in this triangle are congruent to these two angles in that triangle, what has to be true about the third pair of angles?
They are congruent.
They have to be the same. They have to be congruent. So know those theorems. So if I give you this triangle, say that's a right angle, that's 30 degrees. I know that doesn't look right. I give you this triangle, that's a right angle, that's 30 degrees. What can you tell me about that angle right there?
60 degrees.
60 degrees. What can you tell me about that angle?
60.
60 degrees. They got to be the same.
I think we're all done.
Fill in what you need to fill in on this. Things to look for. Things to look for when you don't have any more given information. The 4 ways to prove two triangles are congruent. And then using CPCTC. Corresponding parts of congruent triangles are congruent. Remember that you can only use CPCTC after what?
You prove the triangles are
After you've proven the triangles are congruent. So if you haven't proven two triangles are congruent in your two-column proof, then you won't use CPCTC in it. These first two right here, oops, might want to circle those two. You've got, if you can't pick out those two right off the bat, vertical angles or anything equals itself, in Cameron we're going to have major problems. You've got to be able to pick those out When you run out of given information, those are the first things you should look for. Those are the easy ones.
There was one.
Parallel lines, if you're given information, says something about two lines are parallel to each other, you have that symbol in it, you should look for the Z, or some of the problems were corresponding angles. That's where you smash the two parallel lines together, and then they overlap. Also, don't forget, if they tell you two angles are right angles, somewhere in your proof, you've got to say, not only this angle's a right angle, angle's a right angle, but then in the next step, you got to say that those two angles are congruent to each other. And our reason would be all right angles are congruent. If we use this one a bunch, midpoint, segment bisector, angle bisector.
Yeah.
Yeah, so know that. It's written over here. But over here, it just says midpoint splits a segment into two congruent segments. That could be a segment bisector. It could be an angle bisector, except for an angle bisector, instead of splits a segment, it's going to say splits angle into two congruent angles, so on and so on. None of my classes still have written any of the extra ones and put up there. So I guess we won't have them up there for the test unless somebody does it in the next few days. Segment addition postulate, we talked about that. With the two column proofs, statements, reasons, just going back over this real quick. What's probably your first reason going to be? Given. A lot of times that's what it is. Maybe you might have other givens in there. I'm not going to put the other givens in there for now. We get down here. If number 4 is triangle whatever, that's a question mark, is congruent to triangle whatever, what's your reason over here got to be?
Anything equals itself.
SAS,
Wait, what?
ASA, AAS.
If it's two triangles, your reason has to be side, 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 angle, or angle, angle, side. That's the only thing that can go with two triangles. If there's a statement below the two triangles, then it's got to be corresponding parts of congruent triangles are congruent. How are you going to know when you're using CPCTC?
When the proof is a angle or
When your proof statement
Isn't the triangle.
isn't triangles, when your proof statement is segments are congruent, or angles are congruent, then you know you're going to be using CPCTC. If your proof statement is two triangles, then you're stopping before you get to CPCTC. Next, is this on your notes somewhere?
Yeah.
Thought you were slipping on me.
So if we have to put this
I like
in
touched him in the
in
head
a,
because you were staring at me. I was like, wait.
If we have to put the ISOP,
I'm listening.
if you have to put the thing in like in a 2-column proof, how would you word it?
What do you mean? Oh,
Would you say if isosceles then this? Is that
so
what you said?
so if you were putting something in a 2-column proof and it was, you knew that these two sides were congruent and you were trying to say that these two angles were congruent,
Yeah.
then in your 2-column proof, your reason, whatever number reason that is, let's say number 5, you just write if
Isosceles.
the triangle with the two congruent sides on it, then the triangle with the two congruent angles on it.
Because we had to do one of those on the homework, or the extra credit, and I just put if isosceles then base angles are congruent.
See, that'll work, but that'd just be a shorter way, the way I just did it. So if a triangle's isosceles, you gotta know the different parts. The two congruent sides are called the legs. The angle between those two congruent sides, doesn't always have to be the top angle. It's the angle between the two congruent sides, between the legs, has to be the vertex angle. You gotta remember that. Then the other two angles are called the base angles, and we know that the base angles always have to be congruent. Gotta know these different parts. So even if I draw some triangle that looks like this, and I tell you that these two are congruent, which angle is the vertex angle in this isosceles
A.
triangle? A. And these two angles are the base
Base
angles, and they have to be congruent.
Congruent.
Don't look at how it's drawn every time. The base doesn't always have to be on the bottom. Next one, equilateral triangle. I'm going to draw an equilateral triangle here just real quick. That's terrible, but what do you know about an equilateral triangle? All sides are the same. All angles are the same, and they're all 60 degrees. If it's equilateral, it's also equiangular. Be able to do the two-column proofs. We just sort of went over that, so I'm not going to do a whole lot with it. Just remember the two-column proofs again. Statements, reasons. Triangle something is congruent to triangle something. Then your number 4 here has to be side, 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 angle, side, angle, or angle, angle, side. And if there's a step 5, that reason has to be CP, CTC. Be able to sit up and solve equations just like we were just doing. Oh, one I didn't put on here that I just now thought about it. 3 angles, you might want to write this down somewhere, of a triangle add up to what?
180.
Add to 180 degrees. I'm not sure why I didn't put that on there. At least I don't think I put it on here anywhere, did I?
Yeah, you did.
Is it on there?
It's front page.
I don't remember reading it. Handle all that?
Yeah, but I wrote a 3 backward.
How do you?
It is a solid in one
Where I would write. Yeah. Where I would
I
write.
can
like
write a
that.
cursive E backwards.
I would
but I
write.
don't think I can
Straight
write a
lines
3
backwards. I was
backwards.
like, wait, I forget how to write this.
Hey,
Or like for a straight like 2 months, you write it as a 3, like some letters.
This packet right here is your assignment.
Like my-
Listen so you understand all this. This packet's your assignment. Alright? It's got like 79 problems on it. You don't have to do it all, but listen to what I'm going to tell you. You got to do at least 40 problems. Does everybody understand that? At least 40. Now, with the 40 problems, that's your notes. With the 40 problems, at least
At least
7 have to be 2-column proofs.
7.
At least 7. Does everybody understand that? 40
Yeah.
problems, 7 of them must be the 2-column proofs. So you can't just do the multiple choice and get your 40 problems.
So is this
If you do all of it, it'll probably count as extra credit.
Is this 7? I'm gonna get yours.
So are we not turning in our extra credit thing?
Yeah, I think
We're going to turn it in next time also.
Man.
So you got the extra credit packet due next time, and the review packet.
You're very mean.
Yes, I'm ignoring you, Ethan-O.
Do you think I'll do with the flower?
You look nasty off.
They call him large.
Not doing your job.
I was right there.
You look nasty off.
Hey, so you're not even doing your job?
Yeah, I'm supposed to answer every question.
Pretty funny, but today was just